Okay, so this is the beginning of part 3. We've got now we'll talk about other areas of the brain that are not the cerebrum. So we've got the diencephalon, and diencephalon has all these things in it. We're not going to talk about all of them, but we'll talk about, for sure, the thalamus, hypothalamus. The diencephalon is found between the cerebral hemispheres and above the brainstem. Okay, so it's between the cerebral hemispheres, above the brainstem, and it surrounds the third ventricle. Okay, so it surrounds that whole third ventricle here. There's a picture of the diencephalon. All right, thalamus. Thalamus is kind of just a gateway. It's where all the sensory input heading to the cerebral cortex goes through. All the sensory input except for smell will go through here. It's the thalamus's job is really to send the impulses to the right part of the brain, of the cerebral cortex, okay, for interpretation. So the thalamus, signal comes in, the thalamus sends it to the right part of the cerebral cortex so it can be interpreted there. Hypothalamus is so important. I mean, we're going to talk about the hypothalamus for the rest of this course. That's how important it is, because the hypothalamus is what maintains homeostasis. Okay, it maintains that homeostasis. That we talked about. So remember the homeostasis is that body's ability to maintain a stable internal environment. And it does this by regulating all those visceral activities. So digestion, body temperature, all that stuff. And it also is a link to the between the nervous system and the endocrine system. Okay, so that's why some people call it the neuroendocrine system. All right, there's the diencephalon, and you got. Oops, sorry, I need to get my pen off there. You got this thalamus, and then you got the hypothalamus. The hypothalamus, by the way, has this just below it, has this really important structure. Where did that thing come from? Called the pituitary gland. And remember which bone that was in? The sella turcica of the sphenoid bone. I knew you remembered. Okay. Diencephalon, other parts, well, I shouldn't just say diencephalon, but the limbic system. And I'm going to say this, but in general, physiologists and people, every single thing that should be found or identified within the limbic system. So I'll say this based on what the book has, but with the idea or with the understanding that, not everyone agrees on all parts of this. So the limbic system has all these parts involved, but the limbic system helps to control our emotions, also produces feelings, and interprets those sensory impulses that come in. So limbic system is really important. Emotions, feelings, understanding what's coming in. And, so we went over the limbic system. There's so many other things though you can look at within the diencephalon, and I encourage you to do that. Like, actually go and see what the basal nuclei are, or the basal ganglia. And, because even within those, there's, the caudate nuclei and other stuff. So, the just looking at one thing doesn't mean this is the only important thing within a brain. It just means that within a course like this, we can't look at every single part. But if you're interested in this, I would definitely go look at it. Okay, brainstem. 3 parts of the brainstem: midbrain, superior portion, the pons, middle portion, and the medulla oblongata, the most inferior part of the brainstem. All right, there's the midbrain, kind of a cool picture. Pons, and the medulla oblongata. And remember, this is the foramen magnum right here, so after that you got the spinal cord. Just want to talk back about this stuff. So let's talk about the midbrain. It's between the diencephalon and the pons. Has just bundles of fibers. It's hard to see the bundles of fibers here that join the lower parts of the brainstem with the spinal cord. Lower parts of the brainstem and spinal cord with the higher parts of the brain. So it's really just a highway for stuff to travel. The pons is this kind of a more rounded bulge here between the medulla oblongata and the midbrain. And one of the things the pons does, it regulates the rate and depth of breathing. So people who have who are brain dead, as long as their pons is still working, can still breathe. And I don't know if you remember quite a few years ago in Florida, the case with Terry Schiavo. And she was a woman who was completely brain dead everywhere else, but she had pons and other parts of her hypothalamus still functioning. And so there were basically a legal battle between her ex-husband, who had custody over her medical care, and her family, and because he wanted to take her off life support, and they didn't want her to because they didn't want him to because they felt that she was still alive. So it was a big legal case quite a few years ago. All right, so we said pons regulates the rate and depth of breathing, and also just relays impulses from the medulla to the cerebellum here. From medulla to the cerebellum. Medulla oblongata is, it's really the enlarged portion of the spinal cord after the foramen magnum, and it conducts those ascending and descending impulses between the brain and the spinal cord. But it also has areas for control areas, I should say, control centers for cardiac and respiratory, so breathing and your heart beating, and your vasomotor control centers, so that dilating and constricting of blood vessels. And then there's other non-vital functions to it, like there's this is where coughing is stimulated, sneezing, so you get a tickle in your throat, maybe some dust down there, and it'll send sensory things to the brain, and then the medulla will cause you to cough. Sneezing, swallowing, swallowing food, and vomiting are all control centers within the medulla. Reticular formation, the reticular formation has, once again, are kind of this general area within that brainstem. It extends into the diencephalon, obviously, but and it's kind of scattered throughout the brainstem. It's not continuous in there, and it connects the hypothalamus, the basal nuclei, cerebellum, and cerebrum all together. And the big function of the reticular formation is filtering sensory information. And along with that is our cerebral cortex. When we go to sleep, or even daydream, or even just kind of zone out, the reticular formation can arouse our cerebrum into wakefulness, and it can cause us to wake up. So some of the things that would stimulate reticular formation are light, and because we haven't been for all of our evolution, we have not been living in houses with lights and staying up all night. But quite often, the reason why people get sleepy when it gets dark is because that's when we used to go to sleep, and then we would wake up when the light came up. Reticular formation is also studied a lot in things like jet lag. Okay, types of sleep. We got, and the book has a great description of this, but we've got slow wave sleep, which is the non-REM. REM sleep stands for rapid eye movement over here. But slow wave sleep, you're just tired. Your reticular system starts to decrease its activity. It starts to be inhibited. It's a restful sleep, dreamless, but the slow wave sleep you're not always in the same type of slow wave sleep. You go from light slow wave to heavy slow wave. REM sleep is that rapid eye movement, where some areas of the brain become really active and others are shut down. That's why it's called that paradoxical sleep. Dreaming occurs here, and really we go from this slow wave area to REM. We kind of go in between it all the time, where we're in REM for a while, then we'll go back to slow wave. We always start in slow wave anyway. No one starts in REM. Cerebellum. Cerebellum literally means small brain. It's inferior to the occipital lobes. So here's the occipital lobes of the cerebrum. Here's the cerebellum. And it's posterior to the pons and the medulla oblongata. There's two hemispheres. And connecting the hemispheres is something called the vermis. So just like the corpus callosum connects the two hemispheres of the cerebrum, the vermis connects the two hemispheres of the cerebellum. The cerebral cortex is gray matter, and then there's white matter in there, and that white matter is called the arbor vitae, or tree of life. Okay, and the big functions of the cerebellum are to integrate the sensory signals about where our body is, where our body parts are, where we are in space, and also helps to coordinate skeletal muscle activity. Without the cerebellum, we wouldn't be able to, say, type on a keyboard because we couldn't coordinate that. and other things like maintaining posture happen there. There's the cerebellum. And then this is just a nice little wrap up of all of the major parts of the brain. You know, if you got down to the end of this unit and knew nothing else, I might just look at this part. Now this is in your textbook, this is 11.5, and it's on page 409. Okay. All right, that's it for this first week's lecture.